Today we will discuss about antifungal drugs. As we know that fungal cells are eukaryotic cells just like human cells, animal cells, and they exist in yeast form, mold form and both forms. Fungal infection may be superficial like dermatophytosis while they may be systemic like aspergillosis. And as we know that fungal infections are more challenging to treat as compared to bacterial infections because we have less number of antifungals available in the market and fungal drugs are more toxic to host than antibacterial drugs. Now we will discuss about the classification of antifungal drugs. First one are antifungal antibiotics. They are polyenes and hydrocyclic benzofurans. Polyenes are amphotericin B, nystatin, netamycin, hamycin, and candicidin. Polyenes are obtained from Streptomyces species, while heterocyclic benzofurans like gryzofulvin, which is also an antibiotic, is obtained from Penicillium gryzofulvum. Second one are antimetabolites. They are also synthetic agents like flucytosine. Third one are azoles. They are also synthetic agents like imidazoles and triazoles. They are most commonly used antifungal agents nowadays. Imidazoles include ketoconazole, miconazole, anilconazole, clotrimazole, econazole, sulconazole. While triazoles include fluconazole, itraconazole, voriconazole, posaconazole, turconazole. Fourth category is allylamines. They are also widely used like terbinafine, butinafine, neftifine. Fifth category is ichnocandins like caspofungin, anidulafungin, micafungin. Sixth category is iodides like sodium iodide, potassium iodide. They are inorganic compounds. Many miscellaneous agents may also used as antifungal agents like organic acids, fatty acids, dyes like gentian violet, and sulfur preparations like onion and garlic are also used as antifungal agents in Ayurveda. Next, how these antifungal agents work? What are the mechanism of action of different antifungal agents? First, we will discuss about cell wall inhibitors. These cell wall inhibitors inhibit beta D glucose synthase. Beta D glucan synthase is essential for building the cell wall of fungi, which is made up of NAG, N-acetyl glucosamine. Due to this inhibition, this cell wall is not formed. The drugs responsible are caspofungin, micafungin, anidulafungin. Second is cell membrane disruptors. Polyenes are the antibiotic class which disrupt the fungal cell membrane by binding to ergosterol. They form pore in the cell membrane of fungi and causing leakage of the contents and cell death of the fungi. These drugs are amphotericin B, nystatin, natamycin, candicidin. Amphotericin B is the drug of choice for systemic fungal infections. Systemic mycosis के लिए ये drug of choice है. Amphotericin B also the first drug which was used in systemic mycosis. Next are ergosterol synthesis inhibitors. Let's know the mechanism of ergosterol synthesis. Firstly, squalene is the precursor for ergosterol synthesis. It is converted into lanosterol. Squalene is converted into lanosterol by enzyme squalene epoxidase. Then lanosterol is converted into ergosterol by the enzyme 14 alpha demethylase. So let's move to the mechanism of action of azoles. Azoles inhibit the 14 alpha demethylase enzyme and stop the conversion of lanosterol to ergosterol. These drugs include imidazoles and triazoles like fluconazole, itraconazole, most commonly used antifungal agents. Next is allylamines like terbinafine, they inhibit the squalene epoxidase. So lanosterol is not formed from squalene, and squalene gets deposited in the fungal cell, which is also a toxic metabolite, and cell death occurs. Next is nucleic acid synthesis inhibitors like antimetabolites. These are flucytosine. They inhibit RNA or DNA synthesis by being deaminated to 5-fluorouracil in the body. Next one are mitotic inhibitors. They disrupt the mitotic spindle formation by inhibiting cell division by binding to the tubulin protein. Example, a drug antibiotic glycofulvin inhibit mitotic spindle formation and inhibit cell division in fungal cells. So let's discuss about some interesting facts. Glycofulvin is specifically used to treat the fungal infection of keratinized tissues because it has affinity for keratinized tissues like nails, skin, hair, etc. And why these cells, why these drugs don't put much harm on humans? Because humans have cholesterol and fungal cells have ergostol. This is the difference of selective toxicity here. So thank you for this lesson.